Alright, iChem lesson 20 on percent yield. It's likely that we actually got the chance to talk about this in class today, but just in case, recording this ahead of time. If we didn't talk about it in class today, now it's your homework. Okay, so this idea of percent yield is a pretty simple one. What we've been calculating so far is actually what we call a theoretical yield. So given the amount of reactant reacted, how much of a particular product do you expect to produce? Yield just means how much did you get? And this calculations are actually theoretical. Chemistry is not perfect, and what a percent yield does is measures the reaction's efficiency. How close did this reaction get to completion? How much of the product did we actually make compared to what we expected? So it's a ratio of the actual yield and the theoretical yield. So the theoretical yield, how do we get that? Well, we solve a stoichiometry problem, finding theoretical yield of the reaction. So just as we've been doing the past couple of days, stoichiometry. To find the percent yield, we need to take the actual yield from the problem statement and divide it by the theoretical yield that we find from stoichiometry and multiply by 100. So percent is actual over theoretical. The one given in the problem statement divided by the one that you expect from your calculations. We're going to do an experiment with this in class tomorrow and see how close you guys can get to your theoretical yield with your actual yield. So let's do an example, putting it all together. I have a balanced equation up here. It's already balanced. Of magnesium hydroxide reacting with hydrochloric acid. Okay. It says 45 grams of hydrochloric acid react according to this reaction. You're asked what's the theoretical yield of magnesium chloride. The words theoretical yield may not be used in the problem statement. It might just ask you if 45 grams of hydrochloric acid react, what's the mass of magnesium chloride produced. But what you're doing is calculating the theoretical yield. So first let's do that. Start with your given. So 45.0 grams of hydrochloric acid. I have grams, and before I can get out to my unknown, which is grams of magnesium chloride, I need to go to moles. So grams per mole of hydrochloric acid, from the periodic table, one hydrogen and 2 chlorines, that'd be 36.46 grams. And now that new conversion factor reintroduced yesterday, the moles of my given, which is hydrochloric acid, goes on the bottom, and the moles of my unknown, which is magnesium chloride, goes on top. These numbers come from the balanced equation. So I look up at the balanced equation. In front of magnesium chloride, there's no coefficient, so this is a 1. In front of hydrochloric acid, the coefficient is a 2, so this is a 2. This mole ratio is the only place so far that you're going to have something besides a 1 in front of moles. And finally, I have moles of magnesium chloride. I want grams of magnesium chloride. This is molar mass. 1 magnesium and 2 chlorines is a molar mass of 95.21. So now I want to plug this in. 45 divided by 36.46 times 1 divided by 2 times 95.21. And what I end up with is 58.77 grams of magnesium chloride. this right here is my theoretical yield. Okay, to find my percent yield, it's actual yield divided by theoretical yield times 100. The actual yield needs to be given to you in the problem, or you find it by experiment. This is, someone actually does this reaction. They mixed 45 grams of hydrochloric acid with the amount of magnesium hydroxide they would need, and they actually got 55.4 grams. So actual divided by theoretical times 100. Gives me 94.27%. So my theoretical yield came from stoichiometry. My actual yield came from the problem statement or from experiment. And then my percent yield is actual divided by theoretical times 100.